Hi, welcome everybody. So I see everybody's head turning all of a sudden, so I guess you can all can hear me. So before I start, I'm just a bit curious. Who here would say they are like an engineering manager? Okay, maybe 30–40%. So the rest, I suppose, is the developer. Well, I think 60% maybe indeed, so around 100% here. So my presentation is called How Good of a Developer Are You? And how can we objectively measure this? Because wouldn't that be great? If you're able to objectively measure development skills, then you know who exactly to hire for the needs that you have. And if you're a developer, you can understand where you can improve. Wouldn't it be great if there was some kind of way that you exactly knew how to do both of these things? So my name is Wasse, and I've basically been in the software development consultancy industry my entire career. Once upon a time I studied computer science. I also did a master towards AI, and I worked at different software development consultancy firms. And 7 years ago I decided to co-found Open Value, that is fully focused on the Java software engineering space. So when we started Open Value, we wanted to make sure that we hired the right kind of people, and that we also could communicate with them about how to progress in their career. But how to exactly do that? It's like a holy grail. There are multiple ways. Maybe you can look at what makes a developer a good developer and how you can go about this in a job interview. You can maybe ask some questions in a job interview around well-known acronyms that you see in literature, like YAGNI, you aren't gonna need it, or HATOS, anyone? Hypermedia as the engine of state, or that you read Uncle Bob's book and you can explain what solid is. Well, maybe it's important to understand these principles, but doesn't directly make you a good developer, of course. So I've worked with a CTO that thought that it's really important that you understand the fundamentals of, well, computer science, and that you understand certain algorithms. And he would always ask in an interview, can you please explain how to implement a search algorithm for a balanced binary tree? And if you didn't get this question right, no job offer for you. So I don't know how many times in practice you actually needed to implement that. Anyone? No, I thought so. Oh, one person. So one person, there's one. So not that often. So it doesn't make a lot of sense to use that as a criterion then. Maybe also not the case. You can look at the internet for the most used interview questions there. But maybe the candidate also had a look on the internet as well at the same questions. There's this, well, fairly wild idea of open hiring. So the idea is that everyone has like biases and wants to hire or work with the people that are kind of like himself. And to prevent that, you just put out a job posting and you let anyone start. And after a few weeks, you evaluate the performance and you decide if you want to continue or not. While this is maybe a nice idealistic approach, there are maybe better ways to do some filtering up front, right? And you can maybe use proxy variables for this, like a CV, talk to references of a candidate, use an online questionnaire with programming quiz questions, and maybe also have a look at the educational background and so on. Surely this gives you some information, but being able to program is a skill and not something that you can directly distill from, for instance, a CV. So whiteboard coding might be a good idea during the job interview. But then again, you're putting a lot of pressure on the candidate, and you're also stripping him from the comfort of his own IDE, and you're maybe giving him a sort of task that is not really representative of how the actual coding goes in practice. So also definitely not perfect. Then there's the idea of giving people a homework assignment, ask them to complete like a project at home and turn over the results, and then somebody at your company judges this. There's of course some subjectivity to this judging. And it's a lot of work, so maybe some candidates don't want to go through this process. You might lose candidates that way. So, and I do know about one of our clients. They've been using the same assignment now for a few years. And if you go to GitHub, you can actually find multiple solutions for that assignment. So maybe think a bit more about how to actually measure the skill level. So if you look at the FAANG companies, and for instance Google, they have a pretty elaborate process. So I looked this up at their internet website. They basically do everything That was on the previous slide. So online coding quizzes, virtual chats, in-depth interviews, 3 or 4, you make a homework assignment, and maybe also you need to turn over some additional material. This is a lot of work, that's going to cost you a lot of time, and probably most teams looking for a developer don't have the resources or time to go through this, let alone that a candidate is not willing to go through this entire process. And also, what actually works from all these steps? Turns out there's actually a bunch of really valuable research that can teach us a lot of things. And I ran into this when I started looking into the work of a guy called Gunnar Bergersen, who's an associate professor at the Oslo University, who dedicated his career to finding out what makes a developer a good developer. And while reading his PhD paper, I found a lot of references to all kinds of other research papers, and I'm going to share a few of the things that I found out there. First, there's the aptitude tests. There are quite a few companies that use a test, like an online quiz where you have puzzles and you need to complete certain flowcharts and explain what the outcome is. And that is supposed to give you a good idea about how that will translate into actual programming skills. Well, it turns out already in the 70s that it is actually not a good way to filter out candidates. And there's one study in particular done with 3,500 students. They were asked to either complete a specialized programming aptitude test or the general aptitude test for the United States Air Force. And after they were tested for their programming skills, and it turned out that the predictive power of both of these studies was about the same. And it was really low. So better be careful with using aptitude tests. So what about education? Who here thinks a computer science background is really important? Just a few hands coming up. I was definitely one of the people saying, I want to work with people with a computer science background. It's important you understand the fundamentals, how it works under the hood, etc., etc. But as my career progressed, I met way too many really good developers, architects that studied like psychology or didn't have any degree at all. And yeah, I kind of got to question this, is it really the case? So in a study done in '96, it also turns out that having a computer science background is not a really strong predictor for your job performance as a developer. There's a correlation of just 0.16 between job performance and the educational background of a developer. Shortly after graduation, however, there's a slightly stronger correlation of 0.23. This maybe also is something you can see in your environment. After a couple of years, it doesn't really matter what somebody studied, right? And this is also what a study says, it's just a correlation of just 0.05 after 6 years. So if you put out a job posting, well, and you want to have a senior, it doesn't make a lot of sense, according to this research, to ask for a computer science degree. So what about experience? Surely that is really important, right? And yes, this is also found in a couple of studies mentioned here on the slide. But also in studies, after the first few years, additional experience doesn't really matter. And I think this is something you can also see in practice. Who doesn't know, like, that person with just 3 years of experience, who's quite brilliant, on top of the latest technologies, able to grasp a large complex code base. And on the other hand, maybe somebody that has been working somewhere for 10 years, but kind of stuck at a certain level and doesn't really come with a lot of new initiatives. So asking for 5 to 10 years of experience doesn't make a lot of sense if you're looking for skilled developers. And this is what most companies do, right? So that's not really smart. So what about actual programming knowledge and knowing what's in the API of a programming language and how the flow exactly operates? Is that really important, that you can explain these things? These are the types of things that are being used in all kinds of programming languages certification, like Java certification, for instance, or .NET certification. Well, she did a study and he found out that if somebody has a lot of knowledge about a certain programming language, it's actually a strong predictor of their actual skill. So this is something to take into account. There is some value in certification. On the other hand, I can remember that over a decade ago, I wanted to get a Java certificate, and I just bought a study book. I read it, tried to memorize everything, did the exam, got a really high score, and didn't write a single line of Java code in the process. I would definitely not want to have myself on a development team at that point. So having knowledge about a programming language is definitely something different than being able to program, right? It requires practice. It's a skill. So what is a skill then? Well, a skill is an ability, something an individual can do, like winking your eye. But that's not something you can really improve upon. A skill is a special type of ability, something that you can improve by practicing, and is also goal-oriented. You want to achieve a certain end. And how can you measure the skill level? Because that's what we want to do, right? We want to objectively measure the skill level of a developer, of your own development skills. And there's a nice model here that's created by Drivers and Drivers already in 1980 that describes 5 different skill levels, from novice to master. And to explain these skill levels, you can think about learning how to drive a car. The first time you step into a car, somebody needs to explain to you how to operate the car, where the clutch is, how to shift gears, and so on. And as you actively try to memorize this, you become a novice, and it's costing you a lot of cognitive effort to remember the routines to actually shift gears, put down the clutch, shift the gear, gently let go, push down the gas pedal. But it doesn't come naturally to you yet. And as you practice more and more, you become competent, but you're still not driving really smooth. And as you practice more and more, you become familiar with braking points. And well, you don't have to actively think about all the steps in the routine of shifting gears again. And you're a proficient driver. But as you drive through a busy city center, you're really exhausted once you arrive at home. But at a certain point in time, you become an expert, and the car feels more like one with your body. You're not actively thinking about shifting gears, you're doing it automatically because you've done a lot of driving. And some people, they can reach the master level. These are like Formula 1 drivers, or maybe you know about people who drive with a high speed into their garage and stop the car 2 centimeters before the wall, and it doesn't cost them any effort. So we want to ideally reach the level, if you're a programmer, of a master. And I think you can compare that with flow. If you're working in a state of flow, you're being presented with a problem you want to solve. You're no longer actively thinking about which language constructs you're going to use. You're just typing in your IDE, and it comes to you automatically, and space and time seems to disappear. So these are the types of persons we want to work with, and maybe also the types of developers that we want to become. So is it then all about skill, being a good developer? Well, surely you cannot say if somebody is really skilled, he will be a really good developer. There's more to it than that. A study of Campbell and others said there are actually 3 important determinants of what makes somebody really productive. That is knowledge, we talked about it, skill, but also motivation, right? Now, I think that's actually a no-brainer. In the same study, there were 8 different determinants that make up job performance. And Campbell and the others also said that not all of these 8 dimensions are equally important for all types of jobs. Okay, and this is nice because McGill in 2000 looked into which skills, which determinants, I should say, are important for a software developer. And it turns out that technical skill is the most important thing for the determining productivity of a software developer. So again, technical skill is, well, basically the thing you need to look at if you want to hire a good developer or want to become a good developer. There's some empirical evidence for this as well. Jurgensen did a laboratory study in 2011. He went to a marketplace where people could put out a bid for a project that was being put there. And he looked at the results of those projects and the skill level of the provider completing those projects. And it turns out that skill level of service providers with lower skill level resulted in a 10% increase in failure rate of projects. So again, we see that skill is really important. And what about teamwork then? You can be like really skilled, but if you cannot work well with others, it's also not going to be successful, right? Studies say it's actually quite complex to understand what makes up a good team and how to put it together. But there are some studies that say if you want to have a good team, first of all, make sure that the individual skill level of the people in the team is really high, because that's the biggest contributor to team success. Okay, so all these studies point in the same direction. Technical skill, knowing what you're doing, having a lot of experience with it, is the key thing. So now it's important to understand how you can measure skill level. So I already talked about Gunnar. I have the pleasure of meeting him a few times over the last few years. He made it his mission to understand how to measure programmer skill level. And you see here his work from 2015, measuring programming skill, and a lot of work went into this. You can look it up at Google Scholar, and specifically for the end of creating a platform that is able to meet development skills, he wrote these papers. So he needed to answer the question, okay, how to measure skill. We talked about a few things already, the whiteboard coding, the homework assignments. Those are all subjective ways to measure skill level of a developer. Online questionnaires, also not really suitable. They don't resemble actual programming tasks that you do in an enterprise. You're not working with your regular IDE, for instance, so also not a good way to test development skills. So Gunnar looked at other ways to measure skill level, and one of the things that he thought he could use is something called the Dunning-Kruger effect. So the Dunning-Kruger effect basically says, if you ask any practitioner, for instance a developer, how well do you think you can develop software? People tend to rate themselves too high. But if you ask those same developers, how well would you say a peer would say you are, how well you can develop, then you get a far better answer, a far more honest answer. And this is something that he can use in his research. Then he also needed to understand what kind of challenges he needed to provide for measuring the skill level. So there are a lot of studies around how to measure skills, and there's one paper in particular here that looked at many different studies. It's a meta study, and it basically says you need to find tasks that resemble the actual task that you're doing in practice. So now, knowing this, all Gunnar needed to do is find the right types of tasks. And he found a study from the 1980s done with Lisp programmers that also had the same idea. They wanted to predict how well Lisp programmers would evolve in their career. And Lisp is an interesting language for this because it has approximately 20 different ways to solve programming problems. And it turns out that if you're really good in solving problems with strategy number A, B, and C, then you will also probably be really good with D, E, and F. So this was something that Gunnar could also use. He also needed to put this in a platform because that was his goal. He wanted to introduce the factor time, and he also needed to have a way of determining automatically what the quality of a solution for a task was. So he used some work from Abert for that, and he needed to have some kind of model to plot the outcome of a task and compare it to other developers that also did the same task. For this, he used the Rush model. The Rush model is actually a pretty popular model in psychology. That's being used since the 1960s for measuring reading performance of students. And he changed that model a little bit so he could also use it for measuring programming skills. So now he had all the bits and pieces in place. He picked some existing tasks from literature. He changed that initially for the language Java. He reanalyzed those tasks to also make it possible to use it with the factor time and also to automatically measure the quality of the outcome of those tasks. And he got a nice grant of almost $500,000 that he could use to hire all types of developers from different countries to basically create a control group for the model. He asked those developers to rate themselves with the Dunning-Kruger method, and he made sure he really understood the background of those developers, and that made it possible to initially bootstrap the model in a way that it was possible to compare new test takers to the group that already took the test in the model. But this platform is actually something you can use nowadays. It's called Grabs. It's what we've been using at Open Value as well. We really like it. If somebody has a really high score on this platform, it turns out they're usually really, really good. There are some exceptions still, of course. Nothing is perfect, but it gives a really good idea. If you take a test on this platform, you get an outcome like this. And you get direct feedback about your own skill level compared to the control groups, as you can see. So the person on the left, he scored a bit better than senior. And you can also see that you have different levels here. is not really readable, but you have implementation, coding speed, integration, regression, and the use of OO constructs in this case, and you can immediately see how you score. And the nice thing is you can retake this test with different tasks, and since you're using this rush model, you can compare the outcome with the previous time, so you can also track your progress over time with this approach. So I think it would be great if we would all be using this, because nobody likes to do all these lengthy assignments, these technical interview questions that are way too subjective in many cases. So wouldn't it be great if you could just say, well, you know, I just did the Krebs test last week and I got a 7, so you know about my skill level, so now let's maybe talk about some other stuff than my programming skills in the job interview. So I've been pitching this idea a little bit in the FullStack community, which is an international community for Java developers, and all agree that the current Java certification is not a great way to measure programming skills. It's not measuring skills, it's knowing knowledge about the language, right? And that this would be a great replacement. And we're thinking now about certain tasks that we can use that we think are really representative for measuring Java programming skills with that community. So hopefully this will take off a bit more and we can prevent people from all these lengthy homework assignments and all the other things. So, in conclusion, be careful if you're selecting software developers. Don't look too much at somebody's CV or educational background. Don't ask for too many years of experience. It doesn't make a lot of sense. Coding is mostly about skills. That's the thing that you want to measure, and it's what research shows. And I hope that you are all taking something away for this. And this was my last slide, so thank you very much.